Hello everyone and welcome back again to our channel Tutoring Made Easy. Please, if it is your first time joining this channel, we would like you to do us a very great favor by subscribing to this channel, liking this video and sharing to as many people as possible. Why? The goal of this channel is to make math easy and enjoyable. Yes, we want to make sure that people will be comfortable when taking math classes and enjoy it while they take it along. If you have any form of math topic that you want us to do a video on, feel free and drop it in the comment section below and we'll be more than willing to do a video for you. Also, if you've been watching our videos but you haven't had the time, yes, you haven't had the time to subscribe, please do us a favor and do that. Please subscribe. If you're already a subscriber, I would like to say a big thank you to you for helping us grow our channel. All right, today we're going to look at indices. We've already done videos on indices, but today we're going to solve problems related to indices so that we can be able to apply the laws and the rules that we did study together in our previous videos. If you want to look at the laws, you can go back to our videos and you're going to have access to it. But if you want to stay here too, it's not a problem. You can stay here. Most of our questions we're going to do will be related to the laws as well. All right, we're going to start off with this question. Imagine that the first question we have is 2 exponent 0. Remember, we said the 2 here is called the base. The 2 there is the base, and then the 0 is the exponent. So let's imagine for a second that we have 2 exponent 0. We said that is always going to be equal to 1. Why? Any number raised to the power 0 or any number exponent 0 is always going to be 1. Look, what about the second one? Let's go to the second problem. Let's imagine we also have 10 exponent 1. Anytime you have a number exponent 1, it is the number itself. So what it means is if you have a million to the power or exponent 1, it's still going to be that same number. It's going to be that same number. So remember, we said that if you have 2, for example, we can write 2 in the form of indices by just having a power of 1. We can also write 2 in the form of a fraction by writing 2 divided by 1. We can write 2 in the form of a decimal by writing 2 is equal to 2.0. I hope you get where we are getting at. All right, so let's continue. The third question we have with the third problem, we have 2 exponent 3 multiplying 2 exponent 4. Now, we have to apply a rule here. This is a base, right? This is one of the base, the first base. And this is also another base, second base. And they are equal. They are equal. You can tell they are equal. And the operation sign is multiplication. We are multiplying. And if we are multiplying and the bases are the same, we are simply going to add the exponent. So it's going to be 2 exponent 3 plus 4. Remember, we said if you have a to the power of m multiplied by a to the power of n, we add the exponent a to the power m plus n. And that's exactly what we are doing here. So we are going to get an answer, which is 2 to the power of 7. I hope this is helping so far. Now, let's look at maybe the fourth question. Let's look at the fourth problem. Let's imagine that we have 2 exponent 6 divided by 2 exponent 4. We can rewrite this as 2 to the power 6 and write it in form of fraction, 2 to the power 4. And remember, we had this law that says that if you have a to the power of m divided by a to the power of n, we simply subtract the index, their power. So we're going to have a, or a as a number to the exponent of m minus n, not plus, but minus n. And we're going to apply the same thing here. So we're going to have 2 because the bases are the same and the sign in the middle is division. So we subtract. So here is the same thing. We're going to have 2 exponent 6 minus 4. And we're going to have 2 exponent 2, which gives us 4. All right. Now, let's look at another question, maybe question number 5. Let's say that we've been given 3 exponent 2 all to the power of 5. Remember this law. If you have a to the power of n all to the power of m, we said that it's the same as a to the power of n multiplied by the m, so that we're going to get a and m. So we're going to do the same thing here. It's going to be 3 to the power 2 multiplied by 5, and that gives us 3 to the power of 10. 3 to the power of 10. All right. The next question we're going to be looking at is if we have 2 to the power of negative 3. 2 to the power of negative 3, we said that, remember, if you have a to the power of minus n, we said that write 1 in the numerator, and then in the denominator, just write a to the power of n without the negative. So we're going to apply the same thing. Because we've seen this, we're going to write 1 first. Because there's a negative number on top here, we write 1 in the numerator, and then in the denominator, we just write 2 to the exponent of 3 without the negative sign, and that gives us 1 divided by 8, because this is the same as 2 times 2 times 2. 2 times 2 is 4 multiplied by the 2, and that gives us 8. Is that not incredible? I think it is. I think it is. The next question that we're going to have, the next problem we're going to be having is, it says 8 exponent 2 over 3. 8 is giving us 8 exponent 2 over 3. Now, one of the tricks here is to look at this number 8 and be comparing it to these numbers on top here, and ask yourself, what numbers are common to this 8? You can see 2 and 8, they are common. So is there a way we can write this 8 in terms of 2? So we know we can write 8 in terms of 2 by writing 2 exponent 3, because we know that 2 times 2 times 2 is equal to 8. So 2 exponent 3 all to the power of 2 over 3. And we are going to use the previous law. A to the power of n all to the power of m, we said it's the same as a to the power of n multiplied by m. So we're going to do the same thing here. We're going to get 2 to the power of 3, which is 2 all to the power of 2 over 3. It's the same as 2 to the power of 3 multiplied by 2 over 3. And this cancels this. And we have 2 to the power of 1 times 2 over 1, which is 2 to the power of 2, which is 4. All right. I hope this is helping so far. Now, we have another problem. Imagine we have 2 divided by 3 all to the power of 3. We're going all to the power of 3. We're going to apply a rule that we did the other time. If you have a divided by b all to the power of n, we said it's the same as the numerator a to the power of n, divided by the denominator b to the power of n. So we're going to do the same thing. What is the numerator? Is 2 to the power of 3, divided by the denominator is 3 to the power of 3. And the top part, which is the numerator, gives us 8, because 2 times 2 times 2 divided by 3 times 3 times 3. The numerator will give us 8, the denominator will give us 27, because this times this is 9 multiplied by 3, and we get our 27. We get our 27 right there. So we get 8 over 27. 8 over 27. We are going to keep solving problems, and in this problem we are being told to evaluate. We are being asked to evaluate. And what are we going to evaluate? We are being asked to evaluate this. Into parentheses, we've been given 4 whole number to the power half plus 125 whole number to the exponent of 1/3, and then all of it is squared. Now, we said that if you see a problem and there's no equal to sign in it, we always introduce it with an equality sign. So we're going to still write that 4 to the power of half plus 125 1/3 all to the power of 2. Now, if we look at this number 4 and then the numbers on top of it, what is common is that we can see that 4 is common to 2. So we can write this 4 in terms of 2 by saying it's 2 exponent 2 all to the power of half. Okay, a big bracket, plus this 125, we can compare it to this 3. And we can do that by writing 5 to the power of what? 3, because 5 times 5 times 5, this is 25 times 5, which gives you 125. So we have 5 to the power of 3, 5 to the exponent of 3, all to the power of 1/3, and then we're going to square everything. Now, if you look at it carefully, you can see that this 2 to the power 2 to the power of half plus this 5 to the power of 3 to the power of 1/3, right? If you look at it closely, we can cancel this out, and this can also cancel that out. So in this big bracket, we're actually having 2 to the power 1 plus 5 to the power of 1 all squared. Now, to continue, we're going to have is equal to 2 to the power 1 plus 5 to the power 1 all squared, and that gives us 2 plus 5 all squared, and that gives us 7 squared, which is 7 times 7, and that gives us 48. It gives us 49. It gives us 49. It gives us 49. Now we're going to try another problem, but in this problem, we are told that we should simplify. We are told to simplify. And to simplify, we have 3 to the power of n minus 1 multiplied by 27 to the power of n plus 1 divided by 81 to the power of n. Now, one trick here to notice is that we have the number 3, and 3 is common to 81, and that same 3 is common to 27. So we introduce our equal to sign and write 3 to the power n minus 1 multiplied by the 27. How do we write that in terms of 3? It's 3 to the power of 3, because we know 3 times 3 times 3. These two give us 9 times 3, which is 27. All right. So we have been able to rewrite 27 in terms of 3 to the power of 3. And mind you, this is just 27, but to the power of n plus 1. So please don't forget that. Divided by the 81. It can also be written as 3 to the power of 4, all to the power of n. All to the power of n. Why do we say that? Because this is the 81 to the power of n right there. Okay. Now, we are going to have 3 to the power of n minus 1 multiplied by 3 to the power of 3n plus 3. This is going to multiply each of them because they are exponents at the top. Divided by 3 to the power of 4n. 3 to the power of 4n. Yes. Now, there are some rules that we need to apply here. Yes, if you look at this number, it's the same as this number. The bases are the same. And the operation sign in the middle is multiplication. So we need to add the exponents. So it's going to be 3 to the power n minus 1 plus the 3n plus 3. All divided by 3 to the power of 4n. We're going to have 3. This n, we're going to rearrange. It's going to be n plus 3n minus 1 plus 3. We just rearrange divided by 3 to the power of 4n. We're going to have 3 to the power of 4n plus 2. Do you agree? Because if you look at this, we are owing $1. And then we are using the $3 to pay. The $3 is ours. It's in our wallet. And once we pay, a change of 2 needs to be given to us. And that's why that one is plus 2. All divided by 3 to the power of 4n. Now, the last rule here is division. The bases here are the same. So we subtract their exponents. So it's 3 whole number, 4n plus 2 minus into bracket 4n. Into bracket 4n. So that's going to give us another rearrangement. It's going to be 3, 4n minus 4n, right, plus 2. And that gives us 3 to the power of 0 plus 2. And that gives you 3 to the power of 2, which is equal to which is equal to 9, which is equal to 9. Please, if if it's giving you a little bit of a problem, you can pause the video, take a walk, take a break, drink water, come back, pause the video, go back and forth, and it's going to be very easy. You're going to be able to understand and to be able to comprehend what we are doing, here. All right, we're going to solve one more problem, and I think we can end here. One more problem, and then we can decide that we are going to end here. Now it says, if we have 27 to the power of x multiplying 3 whole number to the power of 1 minus x divided by 9 whole number to the power of 2x, we should find x. We're going to find x. Now, like I said, let's always look at the numbers. If you look at 27 and 3 and 9, they are common. They have 3 in common. So we can write the 27 as 3 to the power of 3 all to the power of x. Yes, because only this is the 27, and we bring the power there, which is x. And we multiply that by 3 to the power 1 minus x and divide it by the 9. 9 can also be written as 3 to the power 2 all to the power of 2x. All to the power of 2x. Now, if you look at this top here, we're going to get 3 to the power 3x. But this and this need to multiply. Multiplied by 3 to the power 1 minus x divided by 3 to the power 4x. Now, it becomes straightforward because we're going to apply the rules. The rules here, we said that if the bases are the same, we add the top. So it's going to be equal to 3 to the power of 3x plus 1 minus x divided by 3 to the power of 4x. And that gives us 3 to the power of 3x minus x. We are rearranging. Plus 1 divided by 3 to the power of 4x. This gives us 3 to the power 2x. Why? This is 3x that we have in our wallet. How do we know it's in our wallet? Because it's a positive 3x. So that one is in our wallet, and then we are actually paying off a debt, something we owe, $1. Once we pay the debtor is compelled to give us a change, and that change is the 2x. And we are going to bring our plus 1 there, divided by the 3 to the power 4x. But we are not done yet. We're not done yet. The next thing is to apply the rule of division if the bases are the same. And that is, write 3 whole number. The numerator, we write this 2x plus 1 minus the denominator's power, minus 4x. Yes, minus 4x. And then this is going to give us 3 whole number, 2x plus 1 minus 4x, which goes to 3 whole number 2x minus 4x plus 1 is equal to 3 whole number negative 2x plus 1. How do we know this? It's because we owe 4, but we have only 2 in our wallet, so we still owe 2. We still owe 2. And then this is where our final answer actually comes from. Yes, our final answer comes from. All right, I'd like us to end here. When we come back again, we're going to look at questions on logarithms. Questions on logarithms. However, if you haven't yet subscribed to our channel, please do us a favor by subscribing, liking this video, and sharing to as many people as possible. We want to grow this channel by making math easy and enjoyable. So please, if you have specific math questions or topics that you want us to do a video on, we'll be more than willing to do so for you. So for now, I would like you to take care, and I'll come to you another time. Bye.